All right, remember to chunk your notes from those problems you just wrote down. Now we're going to take a look at equivalent fractions, only it's different. We're not generating them. You're going to tell me if it is a set of equivalent fractions or not. So let's take a look at, see if I can get my stylus to come in here. Let's take a look at 2/9 and 4/27. Now there are two different ways that we can look at a set of fractions and tell if they're equivalent or not. And this first way I'm going to show you is kind of a nice, easy way. I look at the 2 and the 4 and I can tell that we doubled that or multiplied it by 2. So in order for these to be a set of equivalent fractions, I would have to do the same at the bottom. But 9 times 3 equals 27. 9 times 2 is 18. So if this was 4/18, they would be equivalent. But because on the top we multiplied by 2 and on the bottom we multiplied by 3, these are not equivalent. Okay, so that's the first way. Can you scale over by multiplying or dividing by the same number for the numerator and denominator? If that is not an option, then we have to go a different route. So I'm going to do one more example with you, looking at 2/10 and 5/15. Now, I can't multiply by a whole number to go from 2 to 5. So there is a number I can multiply 2 by to get 5, but if it doesn't come to you right away, then we're going to do this problem differently. The other way of checking if two fractions are equivalent is by getting them both in simplest form. So I look at 2/10 and I'm trying to think, is there a number I can divide the top and bottom by? And I can, it's 2. And I think it's always kind of a good rule of thumb to check 2, 3, even 4 and 5. Usually you can break a number down, and if you have to divide again to get it in simplest form, you can. But always, always, always at least check those numbers. And in this case, 2 divided by 2 is 1. 10 divided by 2 is 5. Now there's a 1 in the numerator, so there's no way that I can simplify that anymore. Now I'm going to take a look at 5/15, and I'm going to say, all right, is 5 divisible by 2? No. Is 5 divisible by 3? No. Is 5 divisible by 4? No. Is 5 divisible by 5? And it is. So now I'm going to check that same number on the bottom. Is 15 divisible by 5? It is. So you can see how I kind of worked through that list. 5 divided by 5 is 1. 15 divided by 5 is 3. So these are not equivalent. And my reason being is that when they are in simplest form, they're not the same number. All right, hopefully you have a good handle on this. There's going to be a few sample problems to do in your Cornell notes on the next slide. Have a great day.